Now we're going to look at finding the dot product of two vectors. So the dot product of two vectors, v, which is AB, and I think it's supposed to be u. Yeah, u, which is CD, is the sum of the product of the horizontal components and the product of the vertical components. So u dot v is A times C, so this A times that C plus B times D. So you multiply the horizontal components, then you multiply the vertical components, and you add that result. The answer is going to be a scalar. It's just going to be a number. Now to find the angle between two vectors, you can use this formula. Cosine of theta is the magnitude, v over the magnitude of v times u over the magnitude of u, which has then the other formula you can get from this is that u dot v is equal to cosine of theta times the magnitude of v times the magnitude of u. Or should I say u dot v equals the magnitude of v times the magnitude of u cosine of theta. Anyway, but this is the one we're going to be using, but there's some other variations of that. Okay, so let's go on to example 14. It says find the dot product v equals 512, excuse me, and u is negative 3, 4. So our dot product, u dot v, or v dot u, however we want to do that, doesn't matter. v dot u is going to be 5 times negative 3 plus 12 times 4. So that's negative 15 plus 48, which is 33. Okay, the next one, find the dot product of v1 and v2, then find the angle between the two vectors. So we'll have this v1 dot v2 is going to be 5 times 3 plus 2 times 7. So that's the horizontal components and then the vertical components. So that's going to be 15 plus 14, which is 29. Now for our angle, cosine of theta is going to be v over the magnitude of v dot u over the magnitude of u. So that's going to be, I think I should correct myself. We're going with the v1, v2 for some reason here. So 1, v2. So let's look at the magnitude of v1. That's going to be the square root of 5 squared plus 2 squared. So the square root of 25 plus 4, which is square root of 29. And the magnitude of v2 is going to be the square root of 3 squared plus 7 squared. So that's going to be the square root of 9 plus 49, or the square root of 58. So our cosine of theta is going to be 1 over the square root of 29 times the vector 5. I don't want to say this. 5i plus 2j. I'm not even sure that's the correct notation for this. Dot the vector. I think I'll leave it like that, but 1 over the square root of 58 times the vector 3i plus 7j. So I'm going to pull this common factor out, not common, I'm going to these coefficients out. So it's 1 over the square root of 29 times 1 over the square root of 58 times what? Let's do parentheses. 5 times 3 plus 2 times 7 So that's going to be 1 over, and we multiply that square root of 29 times the square root of 58. We're going to get the square root of 1682 times, and we already found that to be 15 plus 14. Do parentheses here. So it's going to be 29 over the square root of 1682. So that's our cosine theta. So theta would be cosine inverse of 29 over the square root of 1682. And that's going to give us approximately 45 degrees. That's it. In fact, I don't think it's approximate. I think it's exact, because I think you can reduce this out, because it isn't 58 2 times 29. So it ends up being 1 over the square root of 2, or 2 root 2, which is then going to be, so let me change this to an equals. Okay. The last problem for this video is find the angle between U and V. Okay, so same kind of thing. Our theta is going to be equal to cosine inverse of U over the magnitude of U dot V over the magnitude of V. So that's going to be cosine inverse of negative 3i plus 4j over, and I should have done the magnitude of u. It's going to be the square root of negative 3 squared plus 4 squared, square root of 25, which is 5. So that's a 5 down here, dot 5i plus, this is a j, 12j over, okay, the magnitude of v is square root of 5 squared plus 12 squared. You probably know that one is a Pythagorean triple. You probably knew the last one was a Pythagorean triple. So 25 plus 144, we did this earlier in one of our lessons. Square root of 169, so it's 13. So we'll end up with cosine inverse of, now 5 times 13 is 65. Negative 3 times 5 plus 4 times 12. So cosine inverse of negative 15 plus 48 all over 65. So it's cosine inverse of 33 over 65, which comes out to be 59.5 degrees. That's it. So one more video to go in this collection of videos.